In this video, we'll look at an example of mutually exclusive as well as independence. And so we're going to rely on the two basic formulas for this. So for the first question, probability of A or B equals the probability of A plus the probability of B minus the probability of A and B. So let's just dive straight in. And independence for this one, we're going to use this formula. Probability of A and B, if it is independent, should be the same as the probability of A times the probability of B. Probability of A is 0.4. And the probability that event B will occur is 0.3. The probability that either event A or B will occur is 0.58. So there's the word or, so 0.58. Are they mutually exclusive? Now, if they're mutually exclusive, visually, you would have had a Venn diagram that looks like this. And understanding-wise, if they're mutually exclusive, there is no overlap. So the probability of A and B, the overlap, should be 0 for them to be mutually exclusive. So I'm going to take from the formula I've started filling in, I'm going to take the probability of A and B across so that it's positive. And if I bring everything else across, I get 0.12. That means there is an AND. That means there is an overlap. Therefore, since the probability of A and B is not 0, they are not mutually exclusive. I hope that makes sense. Because there is an overlap, they're not separate circles, they're not mutually exclusive. Are they independent though? So the probability of A times B, this answer is 0.12, and the answer that we got for the probability of A and B earlier, let's just call this the left-hand side, was also 0.12. So I'm going to call this the right-hand side. And so because they are the same, the formula does work. Therefore, because the left-hand side equals the right-hand side, A and B are independent. I hope that you found this little example helpful. If you did, please like this video, subscribe to our channel, and share this with your friends. Thanks.